see if everything's working. Give me 1 second. I'm gonna blank my screen. Pull up my other monitor here. Okay. Window, moving resize, top right. There we go. I actually have quite a little bit to do here.
Is that got the same cup?
Okay. Well, looks like we need to get some AP Bio done real quick. Alright, let's bring out my other thing here. And we're going to... Actually, hold on. I don't think I actually need this. We're going to just use one note here. No, that's for my Spanish class. Bio, right here. Enzyme readings and questions? No, we're doing the protein folding assignment. Okay, here we go. Put this in the bottom corner. Bottom corner, top corner. Put this down a little bit. There we go, perfect. Alright, I can unblank my screen. Hopefully you guys can see that. We're gonna go over the rest of the protein structure assignment here. Okay, let's take a look. Primary structure of a protein is its sequence of amino acids. As an example, let's globular blood protein that transports vitamin A and one of the thyroid hormones throughout the body. Transthyretin is made up of 4 identical polypeptide chains, each composed of 127 amino acids. Shown here is one of these chains, unraveled. Okay, cool. This seems like a beta plate sheet. Where's the primary? Okay, so I did go and ask my teacher about this. He just said that the difference between primary and secondary was that both, well, they're both held up by hydrogen bonds. Yeah, so like they're kind of like folded together. Here, let me show you guys. Open up Canva real quick. You guys didn't understand. Okay, got Canva. Here we go. Okay, so let's say we have our primary structure here. Here's our amino acids.
Cái giấy cục đây trong tủ trong phòng nha. Bằng cái sao đây?
Okay, so here's uh, our groups. No, right? Well, all I know is that they're bound with their carboxyl groups here. Let's have C as their carboxyl group. That's very misleading. Very misleading. Just for this case, let's do C as carboxyl groups, and then it's going to be paired up with the nitrogen. Here's our all over here. Got more, and then he paired up with nitrogen right over here. It's connected together. That is pretty much how it works. I think. Hydrogen bonding every fourth amino acid. Okay, that's good to know. It's going to be every fourth amino acid. Okay, there we go. That might be a little bit better. Hello. Okay. Anyways. Yes, okay, so let's continue on here. Lying side called beta strands are connected by hydrogen bonds between two of the parallel segments. Many globular proteins. Beta-plated sheets make up the core of many globular proteins, as is the case for transthyretin. Okay. Three-dimensional shape stabilized by interaction between side chains. Okay, superimposed on the patterns of secondary structures for proteins' tertiary structure. Shown here is a ribbon model of the transthyretin polypeptide. While secondary structure involves interactions between backbone constituents, tertiary structure is the overall shape of a polypeptide resulting from interactions between side chains, or groups of the various amino acids. One type of interaction that contributes to tertiary structure is called, somewhat misleadingly, a hydrophobic interaction. As a polypeptide folds into its functional shape, amino acids with hydrophobic nonpolar side chains usually end up in clusters at the core of the protein, out of contact with the water. Thus, a hydrophobic interaction is actually called by the exclusion of nonpolar substances by water molecules. Once nonpolar amino acid side chains are close together, van der Waals interactions help hold them together. Meanwhile, hydrogen bonds between polar side chains and ionic bonds between positively and negatively charged side chains also help stabilize tertiary structure. These are all weak chains, also help interactions in the aqueous cellular environment, but their cumulative effect gives the protein a unique shape. Covalent bonds called disulfide bridges may further reinforce the shape of a protein. Disulfide bridges form where two cytidine monomers have sulfhydryl groups on their side chains are brought closer together by the folding of the protein. The sulfur of one cytidine bonds to the sulfur of the second in the disulfide bridge. Single bond, sulfur, single bond, sulfur, single bond, rivets parts of the protein together. So, pretty sure it should be somewhere here. Disulfide bridge, or disulfide bond, same thing. excuse me, may further reinforce the shape of a protein. Disulfide bridges form where to cool. So there are different types of bonds that can hold up a secondary structure. One of them being hydrogen bonds, which is relatively easy to remember. Disulfides also relatively easy to remember, and ionic bonds. Yes, ionic bonds. Cool. Okay. Association of two or more polypeptides, some proteins only. Single polypeptide unit. Okay. Some proteins consist of two or more polypeptide chains aggregated into one functional macromolecule. Quaternary structure is the overall protein structure that results from the aggregation of these polypeptide subunits. For example, what's shown above is the complete globular transthyretin protein made up of its 4 polypeptides. Another example is collagen, which is a fibrous protein that has 3 identical helical polypeptides intertwined into a larger triple helix, giving the long fibers great strength. This suits collagen fibers to their function as the girders of connective tissue in skin, bones, tendons, ligaments, and other body parts. Okay. Collagen accounts for 40% of the protein in a human body. Hemoglobin, the oxygen-binding protein of red blood cells, is another example of a globular protein with quaternary structure. It consists of 4 polypeptide subunits, 2 of one kind and 2 of another kind. Both alpha and beta subunits consist primarily of alpha helical secondary structure. Each subunit has a non-polypeptide component called heme, with an iron atom that binds oxygen. Hemoglobin. So it's just multiple secondary structures bound together by non-polypeptide unit. Okay, a little bit confused, but that's okay. Alright, cool. We get most of that. At least I get most of it. If you guys have any questions, you guys can ask me. Sickle cell disease. Let's see where I'm at here. Oh, wow. That's pretty... Actually, it's not far down. Let me see if there's anything wrong with the stream real quick. Whoa, wait. What did this guy get? What did he get? What did he get? What did he get? Oh, he got a 1400. That's nice. Okay, let's double check. Here. Oh, there seems to be people watching. Oh, wow. That's weird how no one's saying anything. But, I guess you guys are just here to get free information. I'm pretty sure this is illegal, actually, to distribute this information from this textbook. But, hey, we're not that popular yet, you know? Just not yet. I think I have to actually, I think I have to put these streams in private before Pearson finds out. Okay, anyways, even a slight change in primary structure can affect a protein's shape and ability to function. For instance, sickle cell disease, an inherited blood disorder, is caused by the substitution of one amino acid, valine, for the normal one, glutamic acid, at the position of the 6th amino acid in the primary structure of hemoglobin. The protein that carries oxygen in red blood cells, normal red blood cells, are disc-shaped. But in sickle cell disease, the abnormal hemoglobin molecules tend to aggregate into fibers, deforming some of the cells into a sickle shape. A person with the disease has periodic sickle cell crises, even when the angular cells clog tiny blood vessels, impeding blood flow. The toll when taking on such patients is a dramatic example of how a simple change in protein structure can have devastating effects on a protein function. Okay. 8 o'clock, we will get to SAT. Primary structure, secondary, tertiary, normal, beta subunit. Okay. Quaternary structure, normal hemoglobin. Proteins do not associate with one another, which each carries oxygen. Normal red blood cells are full of individual hemoglobin proteins. Okay, cool. Sickle cell beta subunit. Sickle cell hemoglobin, hydrophobic interactions between sickle cell hemoglobin proteins lead to their aggregation to a fiber. Capacity to carry oxygen is greatly reduced. Excuse me. Okay. Fibers of normal hemoglobin deform red blood cells into sickle shape. We're just gonna ignore that background noise. Give me 1 second, guys. Be right back. No, the stream did not indeed end. Just doing something real quick. Okay, we're back. Okay, Okay, we already gone through that. What determines protein structure? You've learned that a unique shape endows each protein with a specific function. What are the key factors determining protein structure? You already know most of the answer. A polypeptide chain of a little bro. What? Unless you're older than me, you can't be calling me little bro. Or if you're some like genius or something. But anyways, A polypeptide chain of a given amino acid sequence can be arranged into a three-dimensional shape determined by the interactions responsible for secondary and tertiary structure. This folding normally occurs as the protein is being synthesized in the crowded environment within a cell, aided by other proteins. However, protein structure also depends on the physical and chemical conditions of the protein's environment. If the pH, salt concentration, temperature, or other aspects of its environment are altered, the weak chemical bonds and interactions within a protein may be destroyed, causing the protein to unravel and lose its native shape, a change called denaturation. Cool, that's nice to know. Denaturation is a very important word if you guys did not know. I already know what it does. That was just destroying the bonds of the folded protein and just straightening it out pretty much. Let me see the definition. Bro. Please? There. No, wait, there. Okay, in proteins, a process in which a protein loses its native shape due to its disruption of weak chemical bonds and interactions. I am a junior right now. 5 viewers is actually kind of crazy. That's the most I've had in a long time. Long time. Current SAT? I know, I have never taken it before. Never taken it. I'm taking it in October 5th. It's going to be my first SAT. Hopefully I can get a 1400 plus first try. It may not be possible. Actually, no, not possible, but it may not be guaranteed. But hopefully my efforts are not going to waste. Anyways, I will get to SAT in 6 minutes. I will finish this up real quick. In DNA, the separation of the two. Yes, I have practiced 2 tests. I'm doing a third one right now. I'm doing the third test right now. And I'm going to go over my thought process with you guys, of course. The separation of the 2 strands of the double helix. Denaturation occurs under extreme non-cellular conditions of pH, salt concentration, or temperature. Okay, cool. Nice. So if you guys were wondering, my teacher... Ignore that background noise. If you guys were wondering what denaturation actually looks like, if you, it's probably a girl's thing, but you've seen, like, hair irons, you can see people curl their hair. Yeah, there's, like, proteins in her hair. Right, I'm pretty sure it's called keratin. Let me just fact check myself. Keratin is a protein? Yes. So it's actually a protein, right? And when we apply extreme heat to it, which is from the hair irons, we actually get curled hair or straightened hair. You can alter the shape of the protein, and in most cases, it'll go back to normal because it folds by itself. That's where we get our denaturation and protein folding. That's a good way to put it. Just learned that today. Let's keep going. Oh, let's look at this diagram here. Yeah, so this is pretty much what it's doing right here. This is just our normal protein, and then after denaturation, it sort of straightens out right here. And then renaturation. Renaturation is just folding proteins. That's pretty much it. After it's been denatured, it renatures. There we go. Okay. Most proteins become denatured if they are transferred from an aqueous environment to a nonpolar solvent, such as ether or chloroform. The polypeptide chain refolds so that its hydrophobic regions face outward toward the solvent. Other denaturation agents include chemicals that disrupt the hydrogen bonds, ionic bonds, and disulfide bridges that maintain a protein shape. Denaturation can also result from excessive heat, which agitates the polypeptide chain enough to overpower the weak interactions that stabilize the structure. Give me 1 second. Anyways, okay, let's see. This also explains why excessively high fevers can be fatal. Proteins in the blood tend to denature at very high body temperatures. Cool. Oh wait, I skipped a couple parts. Denaturation can also result from excessive heat, which agitates the polypeptide chain enough to overpower the weak interactions that stabilize the structure. The white of an egg becomes opaque during cooking because the denatured proteins are insoluble and solidify. Cool to know. When a protein in the test tube solution has been denatured by heat or chemicals, it can sometimes return to its functional shape when the denaturing agent is removed. Sometimes this is not possible. For example, a fried egg will not become liquefied when placed back into the refrigerator. We can conclude that the information for building a specific shape is intrinsic. New word, guys. I'm not familiar with this word. Belonging naturally, essential. Okay, so information for building a specific shape is essential to the protein's primary structure. This is often the case for small proteins. The sequence of amino acids determine the protein's shape, where an alpha helix can form, where beta-plated sheets can exist, where disulfide bridges are located, where ionic bonds can form, and so on. But how does protein folding occur in the cell? Here's our hydrogen bonds, I'm pretty sure. 2 minutes, guys. 2 minutes until we get to SAT. No, I don't want to know. Stop it. Stop. How do I stop generating? Here we go. Okay. Biochemists know the amino acid sequence for over 100 million proteins, with several million added each month in the three-dimensional shape for tens of thousands. Researchers have tried to correlate the primary structure of many proteins with their three-dimensional structure to discover the rules of protein folding. Unfortunately, however, the protein folding process is not that simple. Most proteins probably go through several intermediate structures on their way to a stable shape, and looking at the mature structure does not reveal the stages of folding required to achieve that form. However, biochemists have developed methods for tracking a protein through such stages and learning more about this important process. Misfolding of polypeptides in cells is a serious problem. Many diseases such as Alzheimer's, Parkinson's, and mad cow disease are associated with an accumulation of misfolded proteins. In fact, misfolded versions of the transthyretin protein featured in Figure 3.22 have been implicated in several diseases, including one form of senile dementia. That's funny. Even when scientists have a correctly folded protein in hand, determining its exact three-dimensional structure is not simple, for a single protein molecule has thousands of atoms. The method most commonly used to determine the 3D shape of a protein is X-ray crystallography, which depends on the diffraction of an X-ray beam by the atoms of a crystallized molecule. Using this technique, scientists can build a 3D model that shows the exact position of every atom in a protein molecule. Nuclear magnetic resonance spectroscopy, cryo-electron microscopy, and bioinformatics are complementary approaches to understanding protein structure and function. Bioinformatics 3.7. Let's take a look, actually. 3.7, hello. 3.7, lead me to 3.7. It's not doing anything. Oh, it's probably here. Here's X-ray crystallography. Oh, it's 8 o'clock, yeah. Goodbye, AP Bio. I will see you later. Now, we will head on to our SAT, the thing you guys have been waiting for. Give me 1 second, I have to log in. Hello. Okay, almost done. I'm going to close this. You can stay up here. You can go in this bottom corner. Alright, guys, we are ready. Yeah, somewhere around there. Yeah, somewhere in the West Coast. You can tell from the time zone. Okay, let's resume our test. So, I was actually still continuing this practice test here. Let me go get my pencil. Okay, here we go. Okay, a bus is traveling at a constant speed along a straight portion of road. Straight portion of road. The equation D is equal to T, 30T. D is equal to 30T. Gives the distance D in feet from a road marker. That the bus will be T seconds. So, gives the distance D. Can't see. Oh, right. Thank you. Forgot. Yeah, there we go. There's our problem. Gives the distance D in feet from a road marker. That bus will be T seconds after passing the marker. How many feet from the marker will the bus be 2 seconds after passing the marker? Okay, so let's make sure that we understand this problem. The equation D is equal to 30T. Gives the distance D in feet from a road marker. The bus will be T seconds after passing the marker. Oh, so we just plug in 2, right? So the equation D is equal to 30T gives the distance D. Okay? So 30T gives D in feet from a road marker that the bus will be T seconds after passing the marker. Okay, so we just plug in 2. That's what I'm getting here. So answer. Right, let me double check if the multiplication is correct. And yeah, okay. Okay, a line in the XY plane has a slope of 1/9. So let's actually do the Desmos method, since that we're actually supplied with this tool, luckily. Okay, so a line in the XY plane has a slope of 1/9 and passes through the point 0, 14. Which equation represents this line? Okay, so let's do f of x is equal to a slope of 1/9. So we're going to do 1/9 x passes through the point 14 plus 14. Let's make sure that this is correct. So it is point through 14, and there is exactly 19 units. Currently a junior right now. Let's see here. Okay, so 0, 14 should be around 19. I don't even know why I'm looking for this point. I mean, it doesn't matter. This should be the answer anyways. So we're looking for 1/9x plus 14. 1/9x plus 14, that is our answer. Okay, if x over 8 is equal to 5, what is the value of 8 over x? Okay, so let's do x over 8 is equal to 5. What is the value of 8 over x? Let's actually solve for x first here. To multiply x on both sides, we're going to be given 40. So it's going to be 8 divided by 40, and we're going to be left with that number, 0.2. That should be our answer. You guys can double check real quick if you guys are following along. Um, 40 divided by 40. Yep, 0.2. Seems to be the correct answer. Okay, triangles A, B, C, D, E, F are congruent. You can also flip both sides. Flip both sides. Like 1 over 5 is equal to 8 over x, is what you're saying? X 8 is equal to 5x. 8 divided by 5. I don't know. I think you need to elaborate a little bit. Because I got a different answer. Anyways, triangle ABC and DEF are congruent. Okay, so they're similar is what they're saying. I'm pretty sure that's what congruent means, right? Okay, where A corresponds to D. Do we have the? Nope, we don't have that formula, unfortunately. A corresponds to D, and B and E are right triangles. Okay, B and E are right triangles. So we have a 90-degree angle on both sides. The measure of angle A is 18 degrees. One fifth is equal to 0.2.
Đồ gạt nước á hả?
Okay, I got it. So we have to look at this right here. We're gonna have a 90-degree. Give me 1 second. Let me save my test real quick. I'll be right
Đi
back.
nhà mở được chưa? Cái bên tay trái đó. Cái cần dặn mở thử cho cho biết tờ thân tiên con.
Okay, well, never mind. I'm back.
Mở được chưa? Có được chưa?
Yes, sir. Yes, sir.
Trời mưa hả?
Hold on, guys. I literally have to. It's so annoying. It's always distractions. It's so stupid at this household. Sorry. I was trying to. Yeah, I was a little bit distracted there. Okay, so let me solve this real quick. 1890. And this one must be question mark degrees. Okay, I'm just gonna use the Pythagorean theorem right here. No, wait, no, that's for side lengths. I'm so stupid. Pretty sure they add up to 180 degrees. 18, no, 8, 60, no, 180. Looking at 72 here. Yeah, I'm thinking 72. Okay, which expression is equivalent to m to the power 4? Okay, so m to the power 4, q to the power 4. Yes, guys, I do see your answers, but I have to solve it on my own. I can't just rely on you guys, obviously. It's for my benefit. Okay, I'm writing down the equation here. Okay, so which expression is equivalent? Okay, so let's just multiply these together using give me 1 second, guys. looking at M5Q9Z2. M5Q9Z2. I'm looking at that one. If you guys think that is wrong, make sure to tell me. Go get my own SAT reading grind. Oh yeah. I just finished that reading section actually because I didn't want to go over that here because that'd be a ton of staring, you know. Math is a lot easier to explain and talk about. Okay, the box plot summarizes the masses in kilograms of two groups of gazelles. Okay, based on the box plots, which of the following statements must be true? The mean mass, the median mass. Physics test. AP Physics? AP Physics? Thank you, friends. I will see you guys later. Okay, let's see. Based on the box plots, which of the following statements I'm supposed to be studying for AP Econ? I mean, not really. AP Econ's pretty easy, to be honest. It's just a bunch of graphs. You gotta understand what the graphs are. And a couple terms. They're fairly easy. But if you're taking like multiple AP classes, then maybe like you're gonna have to study a little bit more because there's a lot of AP classes to take, right? But if you're just taking that only one AP class, oh well, that's well, yeah. Well, there's some idiot teachers out there. My econ teacher is really, really good. He's super good. He explains things. He even tells like pretty funny stories too. Like it's really, really rare to have that kind of teacher. I'm kind of very grateful. So let's see. Okay, anyways. Okay, so two groups of gazelles based on the box plots. Which of the following statements must be true? What are the... Hold on, guys. Hold on. I've never gone through line graphs before. I think it's been ages. If any of you guys... if you guys can help me out here. The mean mass. Is this like... statistics or what? Based on the box plots, which of the following statements must be true? What is this? What are these line graphs? What do these boxes represent? Okay, box. No, not that. Okay, I'm pretty clueless here. I'm just gonna have to make an educated guess. Which of the following statements must be true? So there seems to be a wider range of values. This one seems to have a smaller range of values. But it seems like the mean is the second one. The mean of the second one is greater. What's median again? Oh, well. Okay, so median is the middle number. Well, the middle number is... Okay, the median... I think the median will be greater here. Right? Yeah, it's going to be greater. The median for group 1 is... Yeah. Right? Median is the middle values from what I just read. Middle values here. Middle value for this one is 24.5. So I'm just gonna say it's this. Second, or if you think that it's the mean the second one is greater, you just explain real quick. The graph of the given equation is the xy plane intersect at the point xy. What is a possible value of x? Okay, now we're obviously going to use Desmos here because we're not wasting time. So 76, okay, it's 76, and then x squared minus 5. So what is a possible value of x? Let's do y equals, we got 76. That's possible value there. 0.76, negative 9.76. Positive value for x. Negative 9 is a possible value for x. This is our answer. Cool. To estimate the proportion of a population that has a certain characteristic, a random sample was selected from the population. Based on the sample, it is estimated the proportion of the population that has the characteristic is 0.49. That the proportion of the population that has the characteristic is 0.49. The proportion. Okay, with an associated margin of error of 0.04. Based on this estimate of margin of error, which of the following is the most appropriate conclusion about the proportion of the population that has the characteristics? 0.04 is very small. It's a very small margin of error. Yeah, so I'm thinking the proportion is exactly 0.49. Because that's a very small number for a margin of error. Right, so I'm pretty sure. Unless you guys think that's not right, just tell me in the chat. A is the answer. Explain to me real quick, please. But the proportion of the population that has the characteristic. Can you explain to me real quick while I do these other questions? How many points of the graph intersect in the xy plane? Obviously, we're going to use Desmos again. We're not. Well, 0 because they both have the same slope and different intercepts. It's impossible. They're completely parallel. Okay, so let's put up our calculator again. Let's see, in the xy plane, the graph of the linear function f contains the points 0, 2, yeah, the margin of error is very small. So that means it's going to be very near 0.049. Okay, let's actually add and subtract 0.49. 0.49 minus 0.04. Oh, wait, I think I overestimated. I think I I overestimated how small 0.04 was. You're right. No, you're right. You're right. Just gonna leave that. Put that there. Obviously, I got it wrong, but in this case, we're just gonna put it for the sake of good looks. 0.45. Let's plus 0.53. Yeah, that's right. You're right. Should have made the actual calculation myself. Contains the point 0, 2, which equation defines f where y is equal to f of x? The graph of the linear function f contains the points 0, 2, and 834. Which equation defines f where y is equal to f of x? Okay. Well, in this case, we're using Desmos again. Because I genuinely do not know how to solve this in a short amount of time. With written, of course. Okay, this is linear. No, wait. There. 0, 2. Nope, no 0, 2. Let's do f of x is equal to 4x plus 2. Okay, we got 0, 2. and 834. Let's look for 834. 834. There we go. 4x plus 2. Cool. Okay, if x over y is equal to 4 and 24x over ny is equal to 4, what is the value of n? So let's do x over y is equal to 4. Yeah, yeah, I guess, yeah, that's true. I can just plug in the points and see what the value of n in n-word is pairs. Well, it's great, Ronald Wang. I'm still solving it. 24 over ny is equal to 4. Okay, so let's actually isolate. N is equal to 24. X, and y. What is the value of n? X over y. Oh, 24x. Oh. Okay, so that would mean that would be 24. We could simplify this to 24 over... No, 24 over n. Yeah, 24 over n times 4. Times 4. So x over y is equal to 4. So, is equal to... 24 over n. Let's see. Am I right? Times 4? Yeah, times 4 is equal to 4. And then we'll get 24 over n is equal to 1. And then 24 is equal to n. Yes? I wonder who Ronald Wang is referring to. Okay, so the function W models the volume of liquid. Okay, let's write out our equation first. I think he meant to say retarded. I think he misspelled it. Correct me if I'm wrong, Ronald. Let's see. In milliliters in a container T seconds after it begins draining from a hole at the bottom. According to the model, what is the predicted volume? What is the predicted volume in milliliters? What is going on in the chat, guys? Come on. In milliliters draining from the container each second. Okay, because of the function W models the volume of liquid in milliliters in a container T seconds after it begins draining from a hole at the bottom. In the model, what is the predicted volume in milliliters draining from each second? Sorry. So he seems to be draining 4 milliliters every second. So I think this is really D here. Each year, the value of an investment increases by 0.49. Okay, so it seems like a... trying to play Roblox. I can't play Roblox now. Got a little bit of too much going on, but I will be able to play this summer. I'll play some other games too. Just can't do it right now. I just have to study for this stuff. If I get a high score, like I can, not have to take it again. You know. I mean, you're all gonna have to take it at some point. Let's see. Oh, hello, LMAO. Hold on. Increasing. Okay, which of the following functions best models how the value of the investment changes over time. I'm spending way too long on this question, guys. You're right. Yeah, it's gonna be an increasing exponential. Okay. A. No, it's not A. It said it increases. I'm aiming for at least a 1400. 1400 is my goal here. It's a little bit of a stretch, I know, but I'd be surprised myself if I got a 1400 plus. Maybe a 1500, but that's pretty unrealistic, probably. So, okay, let's keep moving. The reason why it's not A is because it's increasing by 0.49. So if we were to write it out in a equation form, we would have to do multiply, 1.49 to the power of x. So it'd be whatever the previous, your original. Should be, 1 point something, But it's increasing by 0.49%. Like, that's literally like in like sentence form, right? You would say 49%. Okay, so the solution of the given system of equations is x, y. What is the value of y? Great, we have a systems of equations here. Let's write down our equations. 24x plus y is equal to 48. 6x plus y is equal to 72. Now, I remember that I could isolate. No, what is the value of I? Because we can multiply 4. Okay, so we can multiply 4 with the bottom equation here. So I'm going to get 24x plus y is equal to 48, and the other equation being 24x plus 4y is equal to 74. Excuse me, times 4. Hello, CR7. So 296, so be 1.49. Oh, hold on, guys. I have to be right back. I'll be right back. Yes, bro. They're genuinely the most annoying things ever. All I want to do is just play video games, you know. I just want to play hop on Valorant, you know, hop on with the boys. But I can't do that. I can't do that. I have to study for this stupid SAT. Okay, anyways, we're gonna continue. Let's see here. Okay, well, what is the value of y? So I did multiply both sides with y. We're gonna subtract. Oh wait, why did I close Desmos? Yes. Or I could do the substitution method. Right? No. Yes, I can do the substitution method. What am I doing? Okay, 24. I don't have much time. 48. 6x plus y is equal to 72. I'm gonna separate y plus 72. No, I'm gonna separate x. Sorry guys. 6x is equal to negative y plus 72. And then x is equal to negative 1 over 6y plus 72 divided by 6. 12. Okay, and then 24 times negative 1 over 6y plus 12 plus y is equal to 28. Okay, negative 4y plus 24 times 12. Hold on, guys. 24 times 12, 288. Crap. Um, 28 minus 28. This is probably really inefficient, guys. I'm sorry. So 260 divided by 3. Not right now. Let's do what you did earlier, because I don't know if this is even right. What is the value of y? Go over to our intercept. Is 80. 80? Just plug both equations in Desmos. Yeah, I know. But like, intersection point is the answer. Just wanted to do it the written method. So I think that's our answer here, 80. Okay, well yeah, let's just do it from now. Let's just not waste time. You know, just for the sake of time, we're not gonna do the written method, even though it's probably good for me. But if we want to succeed, you probably don't need it. Given equation relates the variable x and y. What value of y does it reach its minimum? Negative 27. It's true. It's a waste of time. Function. Bottom. Cool. Yeah. Solve for y for the bottom and... No? It's not? It's not the answer? Wait. Negative 27 is wrong. 14x plus 22. Oh, what value of x? I'm so stupid. Whoops. Whoopsies. You're right. I need to start reading these equations better. I'm in a rush right now, guys. yeah, I know. The function of h is defined by h of x is equal to 4x plus 28. Okay, the graph of y of... the heck? Anyways, the graph of y is equal to h of x, and the xy plane has an x-intercept of a, 0, and a y-intercept. No, I've never taken the SAT. Y is equal to h of x. It has an x-intercept and a y-intercept of 0, b. Oh, so they're just the same. I don't even need this. X-intercept of 0, right? I don't need it. At 0, negative 7, 0. Oh, what is the value of a plus b? So it's just negative 7 plus 28, which is just 21. It's nice to see viewers interacting with each other. This the first time. It's pretty cool, to be honest. Square A has side lengths that are 166 times the side length of square B. Dang, what are you studying for? If you have a 1480. Okay, anyways, side square A has side lengths that are 166 times the side lengths of square B. Area of A is k times the okay, so 166 times square has side lengths that are 166 times the side length of square B. 166x is equal to k, right? Side lengths of okay, square A side length 166 times side length of square B. Area of square A is k times the area C square A substitute side lengths for x. So x, C. I don't think I have enough time. One square has x side lengths. X side lengths. Oh, you're right. What is the value k? The area of square A is k times the area. Just gonna trust. Oh, never mind. Module's over. Crap. Hopefully our score increases though from the previous test. Okay, let's keep going. Okay, which table gives 3 values of x and their corresponding y values? So 0 must be 4. It's obvious this one already. In the figure, line M is parallel to line N. Line T intersects both lines. Okay, what is the value of x? X is going to equal 33, absolute value of 33 minus 180, which is going to be 147. I think this is the answer. Just make sure to confirm, guys. Just confirm for me. What percentage of 300 is 75? What percentage of 300 is 75? So percentage of 300 is 75. So it equals 75 divided by 300 x. So 75 times 300, I think, right? I think that's wrong. That can't be right. No. I think it's 300 divided by 75. I think it's no. Wait. Hold on. I'm not doing this right. Percentage of 300. So it's 300 divided by x, and then multiply x. So 300 divided by 75, right? $75x is equal to 300. Yeah, I divided 375 and I got 4. Where did you get 25? If you mind explaining for me real quick, instead of spamming in the chat, because I want to understand what percentage. Well, I mean, obviously I could Yes. Maybe, probably, but yeah, sure. You can add me. $75 divided by 300, then multiply by 100. No, so I did it wrong? Okay, so what I did... Wait, what percent of 300 is 75? What percent... I think I'm making it confusing for myself. Percentage of... What percentage of 300... Oh, is equal to x. Oh, hold on. Percentage of 300 is 75. What the heck? Yeah, no, I get it. I just did it wrong for some reason. I don't know that. That was pretty stupid of me. Yeah. To help, you can read the question backward, which say 75 is x percent of 300. Thanks for the tip, Crimson. Yeah, I found it. You found it, guys. Okay, so the function g is defined by g of x is equal to 6x for what value of g of x is 54. So we're going to do 54 is equal to 6x, and then we're going to divide 54 by 6, which is going to get us 9. Thank you. No, this is my first time. I'm just studying hard. That's what I'm doing. Okay, so the function f is defined by f of x. What is the value of f of 0? Oh, let's just plug this in. We don't need to waste our time, guys. F of x, 270, 0.1, power of 0. Or no, x, and then f of 0. Right? Now f of x, and then at point 0, right? No, I don't think it touches 0. Did it touch 0? Let's just put 0 here. Oh no, it's 270. Okay, cool. 270. Yeah, something. Okay, yeah. Okay, in the triangle RST, the sum. Yeah, well, I mean. Oh yeah, well, I forgot. See, I'm not that smart, guys. I'm not that smart. Okay, in right triangle RST. Okay, right triangle, 90 degrees. The sum of the measures angle R and angle S is 90 degrees. The value of sine R is root 15 over 4. What is the value of cosine? Okay, so sine of R. Wait, the measures of angle R and angle S is 90. Oh, wait, what? Is this like a... No. How can there be two 90-degree angles? What the heck? Angle R? Angle R and angle S is 90 degrees. Oh, the sum. Oh, wait, whoops. The sum of the if angles R and angle S is 90 degrees. Okay, so angle R. So T must be 90 degrees. Right, and R plus S is going to equal 90. Yes, the sum. The measures of angle R and angle S is 90 degrees. This is sine R is root 15. So opposite over hypotenuse. So our opposite of angle R. Let's do. So we're gonna have at least E opposite of hypotenuse. Our hypotenuse is gonna equal 4. Hypotenuse is gonna equal 4. Root 15. What would root 15 be? Root 15. What is the value of cosine? Root 15. Root 15 cosine. Opposite of R. So this one's probably root 15 here. And then this one is cosine. Yeah, I'm drawing it out right here. On my paper. So 15 plus 16. No, 15 plus. Let's see. Sine of R. So T must be. Oh wait! I get it. Okay, so root 15 is our hypotenuse, right? If we have our hypotenuse, hypotenuse 4, no, 15 is our opposite, 4 is our hypotenuse, right? Because if we have those, we can find our adjacent by doing root 15. And then what is the value of cosine? Okay, value of cosine, got it. Plus x squared is equal to 4 squared. So 15 plus x squared is equal to 16. Equal to 1. Okay, their adjacent is going to equal 1. Adjacent is equal to 1. Hypotenuse is equal to 4. Opposite is going to equal root 15. Cosine S. Dad. I already did AP Bio a long time ago. Just studying for the SAT now. I need to start working on my geometry skills. So what is the value? There's a very active chat here. It's kind of distracting, to be honest. But that's okay. It's a good thing. Space. Yeah, I know. But like usually, I don't do much trig, you know? That's why it takes me so much longer to do these questions. No. I will give it tomorrow. trying to do this right now. Hold on. Oh, so T's are 90 degrees here. And then RS is 90 degrees. TRS, okay, and then RS is going to equal 40. No, 4. And then hypotenuse. And then our right here, our opposite is going to equal root 15. Root 15, and then what is the value of cosine S? Cosine S. Cosine. So adjacent over hypotenuse. Adjacent. So it's going to be root 15 over 4. Root 15 over 4. That took me way too long, guys. Yeah, no. That took me way too long. Way too long. I'm just. See, I can do it, but like, it's just. I hate trig. I thought it would be B. Yeah, I chose B. 10 to the power of x plus 22. Okay. What is the y-intercept of the graph y equals f of x? 0.14. Let me double check. What is the y-intercept of the graph y is equal to f of x? 0.14, right? Right? Is that right, guys? Yes, Ranbeer. I don't know why it took me so long to figure that out. Okay, so figure not drawn to scale. Let me draw this out here. Or do I need to draw it out? 80. Yeah, no, I'll draw it out. I'll draw it out just to make sure. Here we go. It's a triangle. B, D, C, A. And angle, that angle is 90 degrees. And this is 90 degrees. Okay, shown in the figure, AD is equal to 121 over 3. Let's see. 121 over 3, 41. So AD is 41. And AB is... that number. Let me just break down the full equation. AB is 11 square root 130 over 3. Okay, what is the length of DC? DC, okay. AD, AB. Okay, so let's find our hypotenuse for BDC real quick. So if we have our hypotenuse. No, that's not our hypotenuse. No, that is our hypotenuse. Hello, Ethan's second account. It's true. Should I skip? It's the length of DC. Similar oh, they're similar. How'd you know? Hold on. Let me do this silently real quick. I noticed they actually kept the denominator for AD is equal to 121 over 3. That may be a hint here. That'd be great. That'd be great. AD and AB to solve for DB. Yeah, I might have to skip this one, guys. I'll mark this one for review. Okay. I think that's how you do it, right? Translate up 4. I'm pretty sure that's how you do it. Let's do f of 0. It's gonna be 76. I think that's right, guys. If I'm wrong, correct me. Surface area. Um, 1,474 cubic units. Volume is length times width times height, right? So the surface area. Square units of the cube. Surface area is just the area of one face, right? Let me double check. Yeah, that's what I was thinking too. Surface area. What is the surface area? Now, I don't want the... Oh, it's all the faces added together. Four, 7, 4, 5, 5, 2. Wait, hold on. I have to do the stupid thing. Six squares, that makes sense. 6 faces. Yeah. Hello, Protharv. I'm not really in the mood right now. I feel like I'm an actual failure right now, considering I'm using my chat to help me. Like, this really is kind of disappointing. For the function, the value of q of x decreases by 45% for every increase in the value of x by 1. For the function q, the value of q of x decreases by 45%. The value of q of x, 45% for every increase of in the value of x by 1. Chilled. I cube rooted the volume, right? I cube rooted the. Someone told me to cube root the volume. Wait, cube root and square that number. Crap. There's so many things going on right now. This is so confusing. Oh my gosh. It's good review. Good review. This is probably an area I struggle with, so that's probably why they're giving it to me. Volume of so 468 would be the length and width, or length and height. Surface area in square units. It's squared, right? I get it now. Okay. 468 squared. 219024 times 6. Does it even allow me to give that big of a number? I don't think so. Yeah, I don't think so. Square root to 36504. Side of the cube. Yeah, I did cube root it. So let me go through this again. So 552, 78. This would be one side length. There's just the length and the width, right? So 78 squared times 6. Yeah, how in the world did I get that big of a number? Like, I swear that's what I was doing. I swear that's what I was doing. Like not the one before the big number, not the one at the big number. Yes. Sorry. So many geometry questions. Okay. For the function q, the value q of x decreases by 45% for every increase in the value of x by 1. If q of 0 is equal to 14, which equation defines q? Which equation defines q? Hold on, guys. I'm gonna go get water real quick. Dude, I'm genuinely so pissed at this house, bruh. There's always so many things going on. Sorry. It's so noisy. So stupid. I can't even have my own. Oh my gosh. Anyways. Okay, I'm gonna keep going. Okay, for the function q, the value of q of x 45 decreases by 45 for every increase. Q of 0 is equal to 14. So it can't be this one, of course. It can't be that one. It's not that one. 0.55. Function G. No, I'm not cooking at all, dude. I'm so tired and stressed right now. It's pretty bad because I'm about to go to sleep soon. For every increase in the value of x by 1. Yes, well, yeah, I know. I gotta remove that one too. But why is it 0.55? Why is it 0.55 though? Just can you explain to me real quick? Why is it 0.55? The value of q of x decreases by 45% for every increase in the value of x. Oh wait, oh my dude, I can't even do math. What the hell, dude? No. What I was thinking, what I was thinking was 45 plus 55 was 95. Oh my gosh, I'm so stupid. Oh my gosh, this is actually so depressing. Okay, for which of the following tables are all the values of x and their corresponding values of y solutions given inequality? For which of the following tables are all the values of x and their corresponding values of y solutions given equality? Okay, so let's just plug them in. 20, 18. That's not right. 18. 16 is less than, that's 1. 30, 32, that's 1. 42, let's look at that one. Dude, I'm a junior. Yeah, I'm plugging it in right now. I'm doing it in my head. 42, 44. is indeed, yeah, this is a good representation of 5 and 36. 30, 32 y, well, that's right. Good. Thanks. 16, 18, 20, 16, 5, 5, 32. That's right. 7, 40. 7, 42. Sounds right. See? Right? It's 20, 18, 20, 16. Yeah. Not B. Yeah. Well, it wasn't B. Let's go over this one. I don't think I have enough time. I'm just going to go with this one. Which of the following expressions is R a factor of 3x squared plus 20x minus 63? Let's see. This one might be both. Nah, just by looking at it. Write it down real quick. 3x squared minus 7x. Let me just factor it, actually. Minus 27x plus 63. 3x squared minus 34x. No. Okay. So... is R a factor? I don't know. I find English fairly easy to go over. I got a pretty bad score. I can't be saying anything, but I haven't even practiced the writing section yet, which is unfortunate. So let me keep doing this. 3x squared minus 3x squared minus 7x minus 27x plus 63 minus 34x minus 34x minus 34x 34x. Well, I mean, let's just put this together, right? No? Three. I think our 3x minus 7 is our answer here. I'm out of time. Okay. I'm going to blank it real quick. I'm not expecting anything great. At least an improvement from the previous score is what I'm expecting, though. From all the practice I've got. Okay, guys. Just as I thought, it did increase from the previous score. See, it's getting better, right? Right. So, I will go over every single question tomorrow. And it will get better from then on. No, Luke. Think about it. There's like, hold on. Let me see how many tests there are for how many practice tests. Think about it. Hold on. Full length practice. SAT. There's a total of 6 practices. 6 practices. Yeah, I will go over Khan Academy tomorrow. That's something I'll use. But there's 6 practices, and I've taken 3. If I take 3 more, that'll give me what? 300 plus 300 points, right? Right? Like if every test I increment 100 points, like I'll have 1400 by that, right? That's assuming that I improve every single test, which I am. But don't waste them. I guess. But honestly, I don't know when I'm actually ready or not. But I'll probably follow you guys' advice. Yeah, I think it's best if I follow you guys' advice. Alright. Good progress, though. Good progress. I will. I've already taken it at this point, so I'm just gonna have to go over these questions. But I do have to go to bed right now. So, oh wait, I blanked it. That's weird. All right. 70 after doing only practice problems on Khan. Yeah, I'm gonna have to do Khan Academy. Well, it's time, guys. It's nice to know that there's people out there helping me. Truly humbling, actually. There's plenty of other people who are better than me. Sometimes I don't tell myself that. But I'm glad that I'm improving slowly. So that's a good thing. Yeah, thank you guys for watching. I will see you guys tomorrow. Yeah, I'll see you guys tomorrow. Thank you guys for the support. I have never seen this much support in my life. Well, how many concurrent viewers do we have? Let me double check real quick, actually. Let's see my peak concurrent viewers. This might be a record here. Oh, wow, what the hell? I 10 subscribers, wow. Actually crazy. That's actually crazy, what the heck? Hold up. That actually kind of makes me happy right now. Peak concurrent viewers was 18. 18! No, honestly, this is the best way, because to tell myself that I'm not good enough, but like in a way that encourages me to do better, you know, like that's sort of like the Asian way. My mom, I never really realized that my mom was trying to do that, because that's always her method of doing things. But yeah, telling myself that I'm not better, like even though I'm good to some extent, like I have good areas that I'm good at, it's just it's humbling, you know. It's just if you tell yourself you're good, you'll never like improve. You'll think you're perfect, and that's not really the case here. And I think everyone should do that, which is what I'm doing right now. And this chat really makes me feel that way. But anyways, I think I should really go to bed right now. My butt is sweating. My back is sweating. Like, this is not good before bed. Like, I gotta cool myself down. My sophomore year, yeah, I know. Well, I don't know. Well, I mean, yeah, I know that people struggle. It's just nice to know that people are in my footsteps as well. People have been in my footsteps, but okay. I think I should stop yapping. What do I have now? I haven't taken the test yet. Never taken it before. I'm just studying for it right now. I take it next week on October 5th. And now I should stop yapping right now. I'll see you guys tomorrow. Adios.